This is our 10 o'clock presentation around augmented and virtual reality for maintenance and inspection. It's a topic dear to my heart because that's what I live every day. My name is Vincent Higgins. I'm the chairman and CEO of Optech4D. We're a local Houston-based company with offices in South America and in Europe. We work in augmented and virtual reality. We build solutions for oil and gas, aviation, aerospace, construction, and other industries. A lot in and around competency assessment using virtual reality. That is to say, measuring the skill, the ability of a person once they're trained, kind of testing their skill set. And then on augmented reality, things like inspection, maintenance, permit to work, lockout, tag out, some of the heavy-hitting safety concerns in and around some of these heavy industries. We're going to talk a little bit about the industry in general, the size of the industry. But first we're going to talk about Internet of Things and define some terms, because you've seen in the news, you've seen magazines, many of you may be even developers of the technology. There's different terms used for augmented, virtual, mixed. There's other terms as well. So we're going to first start talking about Internet of Things. Internet of Things, as we know, we've seen it a lot. If you go to Best Buy today, how many connected devices can you buy? 5 years ago, there was nothing. Now you see Fitbits and watches and thermostats, and even Samsung has a refrigerator with 3 cameras. So when you're at the grocery store, you can see how many gallons of milk you're missing. Probably not the best use of technology. It's interesting. It's much more interesting for heavy industry in terms of these technologies, particularly augmented reality. And that's what we'll talk a lot about today, is real live use cases around augmented and virtual reality. They're actually in play today. This is not the future. This is not futuristics I wish to have. These are things that are in the field today, being tested, being used. So what we talk about today is not science fiction. It's real as we move forward. All these things are interconnected, all these Internet of Things devices. Imagine if you're in a chemical plant, a refiner, an offshore facility, a manufacturing facility, you have a heads-up display on, and as you walk up to a piece of equipment, it talks to you about its health, viscosity, temperature, pressure. It tells you when it was last repaired. It pulls up the maintenance manuals. It warns you when you're entering a confined space area. Do you have the appropriate protective equipment? Do you have the permit to be here? Do you have your partner? All the different things that are part and parcel of many of these industries. But we are seeing a lot of safety incidents and HSE concerns. And some of these technologies are going to be part and parcel of what we see in the future. So let's talk some terms. We call this at Optech4D the digital reality spectrum. And we're just going to define a couple things. Here we have reality on the left side. We all know and love. The physical world we're in. Then on the other side, we have virtual reality, which is the immersive, disconnected experience from the real world. So I leave the real world with a heads-up display and a 3D audio, maybe some tactile, some devices that help us jump into that world. And you're disconnected from the world. You're transported to an offshore facility or a manufacturing facility or a helipad or whatever the case may be. And you're being trained and assessed in a virtual world on real, live, virtual equipment. Okay? A little closer to reality is augmented reality. And I know I'm preaching to the choir here, but it's just a question of defining terms, right? Augmented reality is a superimposing of data and digital images on the real world. Usually glasses, smart glasses, and sometimes tablets. Taking off glasses, putting on smart glasses, and as you turn your head, as you look around in the real world while you're working on equipment, you have information floating in and around your head. You might have a checklist, a video playing, some live data streaming from the device itself around the device's health, etc., etc. Tremendous value, tremendous ROI around these technologies as we move forward. And then mixed reality, and there's a lot of different terms. There's a lot of money being spent on mixed reality. Mixed reality is that combination somewhere in between virtual and augmented reality. So imagine I have a virtual ball. I have a heads-up display. I see my hand in the real world. I see a virtual ball in the real world. I roll it under a real table and it disappears under the table. That's a mixture of real world and not so real world, right? And if you happen to stop by our booth, Optech4D, we've got lots of examples of mixed reality. The HoloLens is a good use of that technology. And then, of course, we know Pokemon Go, which is infamous in augmented reality. It tells us a little bit about what we do as a company, but not a whole lot. You need more definition than just a Charmander chasing in a downtown area. I came out of the doctor's office the other day and there were 20 people running around the parking lot with their phones and their tablets chasing something. It was really a bizarre scene. So let's first talk about this side of the spectrum, the virtual reality side. We have here some examples of work we've done for some of the major oil companies. Helideck landing officer training. This is about an hour and a half training. It's immersive. This is with the Oculus Rift. You walk into that virtual world. You're in charge of everything that happens on the helideck offshore. You have to choose your helideck assistants. They go and do things. There's a lot of AI involved. On and off of passengers, refueling, and then fires. And we actually have a rollover, a crash of the helicopter into the helideck, pulling out avatar bodies, all that sort of thing. So it's very realistic, very hands-on, and it saves a lot of money. So let's talk about retention rates for virtual reality. This is from the Institute for Applied Behavioral Sciences. We'll see here, in general, about 5% learning for retention for classroom-style learning. And then you go up reading, audiovisual demonstrations. We put virtual training and virtual activities under practice by doing. And we're getting about the same rates as we see from this study. About 15 times the retention rate from lecture-style learning down to practice by doing. And about 4 times the rate of audiovisual learning, videos, things like that. So there's tremendous value in virtual reality training and assessment of people in the virtual. Relatively new concept and idea, just a few years old. The technology is just coming into being. We deal with technologies that are only 6 or 8 months old many times. So it's exciting to see what's happening. Other examples, lockout, tagout. People die. This particular company had 3 deaths that particular year. And with their virtual training, they've reduced that. And it doesn't, in our case, it doesn't replace training. It's rather, after they've been trained, let's put them in a simulator and see what kind of decisions they make. And for lockout, tagout, it's in OSHA's top 5 major safety concerns. People are dying every day because of bad lockout, tagout. Virtual classroom, this is where it can all start. So you start in the virtual classroom with your e-learning. Your avatar sits down. You take in your e-learning. You go out a door and into an offshore facility or a chemical plant and actually do the practical side of that learning in a virtual world. So it's a combination of like e-learning on steroids in 3D plus virtual world training. So let's take an example. People don't buy technologies because they're cool. You may buy a technology off your iPhone because it's a cool app and spend 99 cents or $2.99. But a major corporation is not going to make money unless it has true value. Unless it saves them money, saves lives, or lowers risk, right? If it doesn't do those things, they get tired of it pretty quickly. So an example, this helideck landing officer training simulator saved them, this particular oil major, $2 million the first year, in part because they didn't have to transport people offshore anymore. They did all their training in a virtual simulator rather than offshore. It costs $7,000 a person to be offshore, typically. It's $5,000 to $7,000 a day offshore for training. Let's talk then about how you build these worlds, these virtual worlds. Here are some examples. We have an airplane hangar, a Boeing aircraft. Here we have a generic refinery, a generic offshore facility. So there's a couple ways to build these, and this is somewhat of a challenge. How do you build virtual worlds? Well, in a gaming environment, you usually build them from scratch with assets, and you create these different levels of design levels and things. In the world of industry, it's often through taking CAD models, 3D CAD models of the facilities, pulling them into gaming technologies, and then creating the animations from those gaming technologies. So we have here some examples. We've built quite a kind of a library. We've got about 25 different assets that we can use for our clients, and they a manufacturing facility, an offshore and onshore facility, and different types of aircraft, all kinds of things you can use over and over again in the virtual world. A little bit about kind of supplemental technologies. We want it to be as realistic as possible. As we know with the Oculus Rift, the HTC Vive, or other technologies, you're trying to trick the senses of sight and sound, right? You're putting something on your head, and you're tricking your mind to think that you're seeing and walking around and touching this virtual world that's much, much larger than the room you're in, right? But how do you create that tactile, how do you create that interactive experience? Well, there's a lot of devices and things being built now that help us to create that. And some involve, like this is the Leap Motion Detector. Some of you know that. You put that onto your Oculus Rift, or you put it on into a mobile version of Oculus, like a Samsung Gear or something, and you can scan your hands. And the skin costs extra, by the way, if you want skin on the hands. And you go in and you can turn valves and switches and take control over control panels. And we're doing projects today that involve sitting in a control room in an offshore facility with all of your buttons and levers and everything, and you're looking out the window. You're actually taking control of the pipe laying, the welding, the different things that happen offshore. And it's extremely realistic. We're finding after about 2 or 3 minutes in a virtual world, you've tricked the senses enough so that you kind of know you're in a virtual world, but you're doing the things you do every day in a virtual environment, and it gets to the degree in which the retention rates go through the roof because you're so close to what you're used to that the knowledge that you gain. And of course, in a virtual world, you can do anything. You can create a first-person shooter game offshore, or some of our developers are just waiting for the day where we can add the guns and start shooting at folks on the offshore, maybe zombies or something, but that has to be a paid project, so we're not going to do that right now. So here's some of the things. HTC Vive has tactile feedback. You've got your lighthouse where you can actually walk around the virtual world in a conference room, and you'll walk around in the world of the virtual world. Let's then move over to augmented reality. Here we have an offshore worker, as an onshore worker in a facility, and through the glasses he's seeing a virtual pump, and he's touching different parts, and he's pulling up pricing, and he's ordering parts and doing things in an augmented reality environment. There are a lot of different types of glasses out there. They're getting better. That's been kind of the choke point for many companies on augmented reality. How good is the hardware to support field operations? And it's getting better and better. And there's literally billions of dollars being spent today on augmented reality types of glasses. As you know, Google Glass was not a great success, but it created a excitement and environment around augmented reality that now has led to literally billions of dollars in investment in these next generation smart glasses that are out there. And we keep in close contact with all of them and provide the right solutions for our clients. One thing I'd like to add, and we talk about Internet of Things, it's really important that when you're in the field, say you're with a smart glasses or a tablets, that you have access to the data you need on the spot. And you can imagine if you're in a chemical plant and you've got 25 pumps and compressors and heat exchangers and all this equipment, how do you shuffle through literally tens of thousands of maintenance documents and diagrams and PNIDs and PFDs and all kinds of stuff that you need to do your work? Well, we think that beacon technology is the answer to that. We can use pattern matching with the front-facing camera where you look at a pump and it finds the appropriate information because it recognizes pump 346. But pump 346 also looks like pump 345 and 344. And so that makes it difficult to use kind of a visual pattern match to collect information and associate it with data in the cloud. So we invented what's called the Safe Beacon. It's basically a low-energy Bluetooth beacon that you attach to equipment. And as you walk up to that equipment, it immediately ciphers through all the documents and only pulls those up that are associated with that particular equipment. It also can send warnings like, do you belong here? Do you have the protective equipment? It's an identifier that allows you to have access to the specific information you need based on your location. And I'm sure you're familiar with the iBeacon technologies. If you go to the Apple Store today and you pull back all the iPhone cases, you'll see beacons behind there. And if you have the appropriate app and you have it on, it will tell you, things about the particular product you're standing in front of. So there's a consumer aspect to that. There's even small beacons they put on shoes and different things. When you pick them up, it realizes that you're holding that in your hand through a vibration sensor, and it puts on the screen next to you information or the sale price of that thing you actually have in your hand. So there's interesting marketing opportunities, but I think there's a lot more interest around what we call location-based data. You can also track people. If you have enough beacons in the field, you can track a person with the headset on or with a tablet in hand. And then in case of an explosion or a gas leak, you can pinpoint people's location in the area of concern. So very, very interesting use cases for both beacon technology in combination with heads-up displays in the field. A little bit about what we focus on in our applications. Maintenance, inspection, permit to work, lockout, tagout, confined space. Those are very specific to oil and gas. We're in Houston. But they also apply across other sectors like aviation and aerospace, construction. And then operator man down, which is about tracking people. There are a lot of these high-end cell phones that when there's a quick jerk and then no movement for 30 seconds or more, you can assume that there could be either they drop the phone or there may be a man down, and you can send an alert back to someone and they can check on them as you move forward. And then on the right side is, what's very interesting, real-time collaboration, or what we know as remote expert. With a front-facing camera and headphones and ear and audio, you can do a type of video call back to an expert in the office. And we've built out a very robust back end to track all of that. So imagine you're in your field, a young operator, you're on a piece of equipment you're not familiar with, you have some documents, but you don't have everything you need for the repair. You go into your glasses and you look for the person who happens to be online, who is the expert, because it filters through who is online and who has the knowledge base to help with this particular equipment, and then makes the video call back, and you have a conversation. And you see the expert back in the office, a picture in the lower corner. He sees you in widescreen, everything that he's seeing, whatever you're seeing, he's seeing. You can share documents. You can do the Monday Night Football annotation and say, hey, look at this area, and then on the video screen of the user, you'll see that annotation take place. Very powerful for many, many applications. For folks that a young workforce in the field, semi-retired, even people in their pajamas at home could be working and having an ear for 50 to 60 field operators at a time, and they call in to 3 or 4 years of experience. So this is a little bit about the remote expert, live collaboration, video streaming, supports equipment maintenance, troubleshooting, emergency shutdowns, and you could even go in, if you're suited up in a hazardous area, you have the glasses on, you could have people both local and remote who help guide you through that experience if there's a gas leak or something. Only one person has to expose themselves with the appropriate gear, and many experts can help and see. There's no substitute to see something from the eye of the beholder, is what we're finding. One thing is to have your phone and be taking pictures or have some localized camera, but when you're in the middle of it and you see the person doing the work up close and you're an expert in the office, it's of great value. So a little bit of the ROI, the return on investment. Companies are not going to invest in these things unless they see an ROI, right? So Boeing has been doing this for about 10 years. They built their own hardware, their own software, and they've been testing out augmented reality technologies, mostly in the manufacturing space, in and around wing assembly, kind of complex wiring. And so all those instructions and the step-by-step procedures are coming up in the smart glasses. And what they're finding is, this is for their wing assembly in Seattle, 30% faster and 90% more accurate for their wing assembly, based on what they're... So the old-fashioned way is a laptop computer where you're doing this, you're going back to the laptop. So you're constantly being disconnected from the effort. When it's in your field of view and you're just continually working, you just glance in the corner of your eye and you see the next step or the diagram, it just lowers the possibility of error exponentially. And we've got lots of different use cases we can talk about. So what are we trying to do in our business is bring together virtual and augmented reality. That's our long-term goal. The hardware isn't quite there yet, but imagine you're in the field Let me just grab one of these headsets. This is an industrial set of smart glasses, right? Imagine you're in the field, and this is completely autonomous. There's nothing to connect to it. It's its own computer. It's got, camera, audio. It's got 64 gigabytes of RAM. It's got basically a tablet computer you wear on your face, right? And imagine you're in the field. You're doing your work. We try to keep the field of view clear, so you can do your work. You turn to your left. You might see a PDF or a checklist or a step-by-step instruction. You turn to your right. You might see a video. You're doing that work in the field. And then you go back to your bunk on the offshore. You put on, pop these out, you put on a darker shade, and these become your virtual reality immersive glasses for doing virtual training. Now, the field of view isn't the greatest at this point, but over time we're seeing as, next generation, the generation afterwards, you'll see that these actually are a great combination of virtual and augmented reality in the same platform. And there's a huge disconnect, particularly in oil and gas. People go from the offshore, go into a classroom onshore, they'll spend a week, hotels, travel, huge expense. And it's mostly check the box. They watch the PowerPoints, they watch some videos, exploding this, exploding that, and they go back into the field, and it's not impactful. It's not helping them. It's just a checking the box. If you can have refresher training, ongoing training in the field, first of all, saving money, and where it's actually measuring your competency. You have to do things, make decisions, and it's measuring you in real time. And that's what virtual reality assessment does. It actually measures your decision-making practices. Our offshore helideck landing officer training has almost 250,000 possible options as you go through the simulation. You go this way, and there's a decision tree that brings you, if you go to do this, then there's 8 things you can do there. It brings you down these rabbit holes of decision-making. And all of that is tracked, and you can see how well you respond to a crisis-based scenario. So the idea of work as you train, training as you work, we believe is the answer for long-term for a lot of industries. And this virtual and augmented reality technologies coming together is a very good answer for bringing that into play. So we're very excited about that. Industries that we play in, all kinds of heavy industry. A little bit about the hardware. It's, I'm sure if you're in this conference, you all are watching and studying hardware, software in one form or another. I don't think we have any uneducated folks on this technology in the room. I can tell by nodding of heads here. So this is what's out there today. Billions of dollars are being spent. We work very closely with Epson. They're coming out with some new ruggedized glasses that we have them in the office that are very good. ReconJet was just bought by Intel. ODG, they're further along with the ruggedized and intrinsically safe. We have the Daiquiri helmet, which is $15,000. If you want to spend that for a helmet, go right ahead. HoloLens, and of course tablets. So all of these are advancing every year. 2017, I believe 2016 was the year for a breakthrough in hardware and VR. The HTC Vive, for instance, is an amazing tool, and that will continue to improve, as well as the Oculus. 2017, 2018 will be the big years for augmented glasses. I believe that they're finally getting there. And it's very hard to miniaturize things to a degree in which you can put a tablet computer on your head. It's just very, very difficult. And yet, these technologies are advancing leaps and bounds. On the virtual reality side, we do a lot of work on a 2D screen, 3D world on a 2D screen. We have some of the technology which I'm sure you're familiar with, and then the mobile technologies where you put your phone into the glasses, and of course the dome. We use the Igloo. It's a 360 degree shared experience where you can have multiple people walking up or climbing the stairs of a distillation tower and having a conversation about maintenance before they go out and do it. It's a great planning tool. You have access to the whole facility in a shared environment. So in some use cases, this is very, very exciting to have the ability to have a cave to be able to walk in and around the actual facility in real time. I'm going to show you a quick video on first on augmented reality, just some images and things. This is the type of quality you'll see in the glasses as you take the manufacturer's CAD diagrams. This is on a tablet. This is a jet engine. You can take these particular parts, isolate those parts, see if they're available in an Amazon type store, et cetera, et cetera. Here's a simple centrifugal pump. You have all kinds of documents that you associate. In this case, a startup checklist is available to you. A lot of what these are driven are paper. Most of what we see today in oil and gas, and to a large extent in aviation, is still paper-based. So it's a pretty big jump, but imagine the value of having everything digital. And here you see you can order parts into different systems. Here's the safe beacon technology. Up comes the tablet or the glasses. It knows it's in front of a particular pump in this case, and it pulls up the manual for that pump or other documents associated with it. And this is, pattern match recognition. Again, not as useful in the field for field operators because of light conditions and the fact that it's hard to identify specific equipment when the equipment looks a lot alike. But it's certainly very cool, isn't it? This is a little bit about the remote expert. So you connect up, and this particular device uses a ring technology, but a lot is moving towards voice commands and gesture. So you can move windows around, touch in the air. It kind of looks funny if you're not in the glasses. Remember in the old days of cell phones, you have that piece in your ear, and you think it looks like you're talking to yourself. Well, people get used to that, and I'm sure they'll get used to this as well as people start making gestures in the air with these technologies. On the virtual reality side, as we talked about, it's all about first bringing in the facility into the virtual world. This is our offshore rig. We've done a lot of interesting work with it. It's very detailed. Every aspect of day-to-day operations can be simulated. Our generic refinery chemical plant. It's amazing how immersive it is. You really think that you're there. All of the sounds, the compressors, all the equipment you're hearing in and around you. It's quite, and if you want to stop by our booth, you can try. Any of these you see here are available to try out. It's a full-blown application. You choose your ethnicity, your role, your mission, your equipment. Here you see, depending on the mission at hand, you choose from a library of equipment. And you can stop here, and it will say, stop, you're wearing the wrong equipment, or you can wait and injured, blinded, burned in the virtual world because you're wearing the wrong equipment. So it's quite realistic that way. You'll see the consequences of your actions pretty quickly. This is more educational, so I'm in an onshore facility. I'm throwing up videos, pulling up information. It's more an educational tool for folks in the field who are just learning the ropes, or for folks in the office who may sell large equipment but don't have the technical expertise. You can even go downhole and simulate what the activity that's happening downhole as you're taking control of the choke and the driller's panel and those sorts of things. This is the offshore facility. That's Bob, the avatar. We named him. You can change views. You're inside the helicopter. You can crash the helicopter. We really enjoy crashing things in the virtual world. At least our developers do. It's quite realistic. Largest pipe-laying vessel in the world. We took the CAD models. We take control of the vessel, and you simulate all the day-to-day operations, both good and bad, that are occurring. So in essence, our goal as an organization is really to bring to light, to educate different industries about augmented and virtual reality, the value proposition in and around that, to educate them on hardware and software, and then, of course, build solutions which will have an impact on their lives and hopefully save lives as well. So that's my presentation. Any questions about the technology? Yes.